Let's do some of these problems together to get you started. So on number 1, the first part of the question wants to find the x. Y at time I transition second down by negative meters. So you'll do the same thing for the rest of the question. Look ahead. You want to figure between my old best and I want this to the I can write my displacement to d delta sub f minus delta sub I. Delta sub I is my start point, my start position. Okay, so at point B, I'm going to find my position. I'm going to look over and delta I negative 5 meters. My end point is going to be y-axis f and negative. Now I can delta equals negative 5 meters. Oops, sorry. I wrote that down wrong. Final position was negative 2. Okay, yeah, meters. Final end position, negative 2 meters minus negative 5 meters. This is the same as writing negative 2 meters plus 5 meters. So delta D, my displacement, is 3 meters. And that's my answer. Number 3 gets a little bit more complicated. So again, I'm going to erase all this to get it out of the way. All right, so for number 3, we're asked to find the velocity between points C and C. Our equation here, velocity. I'm going to rewrite it here. Velocity equals my final or end position minus my start positions over my final time minus my start time. So first, let's figure out what df equals and di equals. So my final distance from points B to C is going to be where C is starting. So my final position at point B is negative 2 meters. My start position is at point B, and if I draw a graph here, I see I'm at negative 5 meters. Now I need to do the same thing with my times. So my end time at point C to the x-axis, and I see that's 11 seconds. My start time is at point B. I'm going to move vertically to the x-axis, and I see that my start time equals 5 seconds. Now I've defined all my variables and plugged them into the equation. So my velocity, my speed, in this case I guess velocity. So my velocity here is d sub f minus d sub I, so negative 2 meters minus negative 5 meters divided by my final time minus my initial time, so 11 seconds minus 5 seconds. This is going to be the same as 3 meters divided by 6 seconds. I'm just going to scroll down here a little bit. So my velocity is going to be 1/2, or 1 meter over 2 seconds, which equals 0.5 meters per second. And there's my answer. I'm going to be doing the same thing for number 4 when I'm finding the object's displacement between points B and D. The difference being here is that now I want to find out what my velocity or the displacement from this point B all the way up to point B. So this is going to be my start point. This is going to be my end point. So when I find my d sub I and t sub I, it's referring to this point, and d sub f and t sub f are going to be referring to that E. And I've actually skipped ahead a little bit because we actually, for number 4, it only asks for displacement. We don't need time for displacement. Displacement just has to do with the distance. So I'll just be worried about d sub I and d sub f for number 4. But number 5, we want to know the object's velocity between, and that's when you're going to have to use time